So now I am going to read the question number 6. Consider a system of two identical masses. One is dropped from a height and another thrown from ground with speed u. The acceleration of center of mass of the system at time t is, and in the given problem one is going down and one is moving up. But the important thing is acceleration due to gravity will act in downward direction for both cases. So if I take the formula of acceleration of center of mass, we'll write m1g plus m2g, because the formula is m1a1 plus m2a2 divided by m1 plus m2. a1 is g and a2 is g. So if I take a small g as a common, so m1 plus m2 divided by m1 plus m2. So we'll see acceleration of center of mass of the system is only g. So my option number 2 is correct. So let's move on question number 7. If I go for question number 7, a block rests on a rough plane whose inclination theta with the horizontal can be varied. Which of the following graphs shows the variation of limiting frictional force? And we know the maximum value of static friction is called limiting frictional force. In the case of inclination theta, the limiting friction given by mu m g cos theta, and we know that if theta will increase, then value of cos theta will decrease. And on the other hand, we can say the friction force is directly proportional to cos theta. क्वेश्चन में बोला जा रहा है कि थीटा विद द हॉरिजॉन्टल कैन बी वेरीड. As I said, if theta is increased, then value of cos theta will decrease, and nature of the graph will be in terms of cos theta. So there is no hesitation. My option number 2 is correct. So let's move on. Question number 8. So if I go for question number 8, a car start from rest at time t equals 0. AT graph as shown in the figure. Okay, a coin is initially at rest on the floor. A coin is rest on the floor. Okay. At time t is equal to 1 second, the coin begins to slip and it stops slipping at t equals 3 seconds. The coefficient of static friction between. So I would like to explain something. When coin will start to slip, then the type of friction is kinetic friction, but we need static friction. So we will concentrate on this time t is equal to 1 second. First I am going to the given graph, AT graph. So if I use the equation of straight line mx plus c, so y can be replaced by acceleration, m, and x is replaced by time t plus c. But as per the diagram, the value of c is 0. So we'll get a is equal to, I need the slope m, and slope m is calculated by tan theta. Tan theta is, this is 8 upon 2, so we'll get 4. If I take total, so the acceleration is given by 4 into t, if this is my equation number 1. So this is the equation for the given graph for t. And we know that if friction force is greater or equal to the external force, then coin will not move, because we need static friction. So if I use this relation, we'll write mu mg is greater or equal to ma. M is the mass and a is the acceleration. So mass will cancel out. So we will write here mu g is greater or equal to acceleration. So if I use, because the coin begins to slip and stop sliding, so we will write here, because I know the value of acceleration is 4t and that is equal mu g as per our discussion, but we will take time t is equal 1 second, because 1 second के बाद ये स्लिपिंग स्टार्ट करेगा और उस टाइम पर जो फ्रिक्शन होगा वो होगा काइनेटिक, बट मुझे चाहिए स्टैटिक। तो इस t की वैल्यू को मैं 1 सेकेंड पुट करूंगा। सो इफ आई प्लेस द वैल्यू ऑफ टाइम t, then mu is equal to 4 into 1 divided by g, and g is equal to 10 meter per second square. So on solving we'll get 0.4. So this is the coefficient of static friction between the floor and the coin is 0.4. So my option number 2 is correct. So let's move on question number 9. If I go for question number 9, in the diagram shown, the coefficient of friction between the block is equal to mu. Find out the maximum angular speed with which the system can be rotated so that no slipping take place. And you have to be very careful, m1 is greater than m2. So if I go for the free body diagram, first I am going to concentrate on m1 because m1 is greater than m2. So we'll see tension T on the left hand side as per the given diagram, and because m1 is greater than m2, so this m1 will experience a pseudo force on the right hand side, जिसको हम लोग रोटेशन मोशन में सेंट्रीफ्यूगल फोर्स भी बोलते हैं। तो block has a tendency to slide on right hand side. That is why we can say the friction force will act on the left hand side. On basis of that, if I go for the block M2, so friction force will be there F and the tension T on the left hand side. This is for M2, right? So if I go for the block M1 and if I want to make an equation, so we are seeing that the tension T and friction force F will act in the same direction, and that is equal mv square by r. If I convert this v in terms of r omega, so we'll get m1 r omega square, and this is my equation number 1. Similarly, if I go for M2, so if I go for M2, तो मुझे ये दिखाई दे रहा है कि टेंशन T and friction force will act in opposite direction. So we'll write tension T is equal to F plus M2 R omega square, because R is the radius. This distance R will play the role just like a radius. So this is my equation number 2. So if I place the value of tension T from equation 2 in equation number 1, so we'll get F plus M R omega square, and 2 is there, and plus friction force F, that is equal to M1 R omega square. But I need to calculate omega, so if I take omega as a common, so we'll get omega is equal to 2 times of mu m1 g divided by m1 minus m2 into r, because omega in terms of square, so there is a need of root. So the final value of angular speed is 2 mu m1 g divided by m1 minus m2 into r. So my option number 1 is correct. So let's move on question number 10. So now I am going to take the question number 10. A small block of mass 1 kg at rest on a parabolic surface given by y is equal to x square. The coefficient of friction between the block and the surface is enough to prevent slipping. This is very important point. If position of block on surface is 2 meter, 4 meter, then the normal force that the surface exert at this position is. So if I make a imaginary situation, or if I consider the given situation just like a inclined plane, so you know this is 2 meter and this is 4 meter, and the position of the particle is this. If I consider for short time, this angle is theta. But according to the problem, equation is y is equal to x square. So if I go for the value of theta or slope, so in terms of slope, if I differentiate, we'll get dy over dx is equal to 2x, and dy over dx, you know very well, is given by tan theta. 2 into the value of x in this question is 2, so we'll get tan theta is equal to 4, and this tan theta will play very important role in the coming situation. So tan theta is equal to 4. So if I go for a triangle, theta, tan theta is 4, perpendicular is 4, and base will be 1. So if I go for hypotenuse, so that is root 17. And why we are going to solve this? What is the need of this? Because I need to calculate the normal force, and you know very well, in this situation, normal force is given by mg cos theta. So I need to calculate the value of cos theta. So now, if I place the value of mass, that is 1 kg, 1 into g, and value of cos theta, you can solve the value of cos theta by using this triangle. Cos theta is given by base upon hypotenuse, so that is 1 upon root 17. So the final value of the normal force is g upon root 17. So my option number 4 is correct.